Good day, viewers. Today we will going to discuss about exponent. But what is exponent? Exponent tells us how many times a number will be multiplied by itself. This expression a, which is written as a raised to n, a here is called the base, while n is the exponent. This expression can also be written as a to the power of n.
After knowing the definition of exponents, we will now proceed to the laws that we will use to simplify the expressions involving exponents. This is known as the laws of exponents.
By exponents, which are positive, we will use the laws of exponents. One of these is the n power of a. But what does this rule say? The rule tells us how many times the base will be multiplied by itself. It is in the form of a raised to n is equal to a times a up to n. For further information, let's give some examples. Example number 1. 5 raised to 3 is equal to 5 times 5 times 5 is equal to 125. As we can see in the example number 1, the exponent is 3, so the exponent taught the base to multiply itself 3 times.
Law is power of power. It is where the bases are the same but different exponents. It is in the form a raised to n times a raised to m is equal to a raised to n plus m. You just have to add their exponent then copy the base. For example, x raised to 4 times x cubed is equal to x raised to 4 plus 3 is equal to x raised to 7.
This next rule involves division, and it is known as quotient of power. Let's say I were to ask you, what 3 to the 5th power divided by 3 to the 2nd power? Well, we can just go to the basic definition of what an exponent represents and say 3 to the 5th power means multiply 3 5 times over 3 squared, which means multiply 3 by itself. We all know how to simplify fraction. And we know that 3 over 3 is just equal to 1, and those 3 over 3 in our problem can be cancelled out. In our case, we have 2 of those sets which leave us with 3 times 3 times 3 in the numerator over 1, or simply say 3 to the 3rd power. Or in general, a raised to n over a raised to m is equal to a raised to n minus m, when n is greater than m.
Next is power of a power. The rule power of a power simply means when raising a power to a power, multiply the exponents. It is in the form of quantity a raised to n is raised to m is equal to a raised to m multiplied by m. For example, quantity x raised to 5 is raised to 6. Simply multiply the exponents. It is equal to x raised to 30. Next is power of a product. It is expressed as quantity a b raised to n is equal to a raised to n b raised to n, where n is an integer and a and b are real numbers. For example, quantity 3x is raised to 2. Just simply distribute the exponents and the answer is 9x raised to 2. In this example, you can see how it is work. The power rule tells us in raising a power, just simply add multiply the exponents.
The power of a quotient. In this case, the first law is applied to simplify the expression, but the bases are in a fractional form. The concept a raised to n we apply the quantity a times b raised to n is equal to a raised to n b raised to n. Therefore, a over b raised to n is equal to a raised to n over b raised to n. Let's cite an example. 1/2 squared is equal to squaring the numerator and denominator is simply equal to 1 over 4.
The rules discussed a while ago are directly applicable in expressions with positive exponents. Now, we will discuss the law wherein exponents are negative. Let n be a positive exponent. Given expression a raised to negative n, it will be equal to 1 over a raised to n. For example, 3 raised to negative 2 will be equal to 1 over 3 squared or 1 over 9. However, if it is a non-zero number and m and n are equal, then the form a raised to m over a raised to n will be equal to a raised to m minus n, which is equal to a raised to 0 is equal to 1. For any non-zero a raised to 0 will always be equal to 1. For example, 5 raised to 3 over 5 raised to 3 will be equal to 5 raised to 3 minus 3 or equal to 5 raised to 0 is equal to 1.
After discussing different laws of exponents, we now go to fractional exponents. But before that, we need to know what are fractions. Let there be a fraction m over n. It is stated as proper if m is less than n. Otherwise, it is improper. If we let a fraction be an exponent in the form a raised to 1 over n, we need 3 cases to evaluate this expression. First, if a is positive real number and n is an even positive integer, then a has exactly 2 real roots, 1 positive and 1 negative. Second, if a is positive or a negative real number and n is an odd positive integer, then there exists exactly 1 real root of a, the sign of the root being the same as the sign of the number. And lastly, if a is a negative real number and n is an even positive integer, then a has no real root. After discussing the definition of fractional exponents, we will now go to the properties of fractional exponents. Given a, m, and n are natural or counting numbers, there are 3 cases to evaluate such expressions. First, if you have a raised to 1 over n, you can simply write it down as the nth root of a, for n is greater than 1. Second, if you have a raised to m over n, you can simply write it as the nth root of a raised to m, for n is greater than 1 and n is positive. Last, if you have a raised to negative m over n, you can simply write it as the nth root of 1 over a raised to m, where n is greater than 1. We take a look of the definition of radical. A radical is defined to be an algebraic expression that takes the form of nth root of a, which is read as nth root of a. understand it more, we should do some examples. We need to change the exponential form to a radical and tell whether it has or has no solution. First, a raised to 1/3. It is just equal to the cube root of 8. And it has exactly one solution because 8 is a real number and 3 is an odd positive integer. Next, 4 raised to negative 1/2. It can also be written as the square root of 1/4. Since 4 is a positive real number and 2 is an even positive integer, then it has two real solutions. Lastly, negative 4 raised to 1/2 is just equal to the square root of negative 4. Since negative 4 is a negative real number and 2 is an even positive integer, therefore it has no real solution.